This is our robot chicken, the cheese edition.
Last season, we learned a lot about robot design. In the off-season, we redesigned Chicken to have a more cube-like design, with our hub between the wheels at the center of gravity. This cube-like design allows us to easily place and remove attachments from Chicken. During the season, we found a problem with our robot design, specifically the wheels. The wheels that we originally used were not stable, had bad traction, and got dirty quickly. So as a solution, we decided to use more stable wheels that had better traction and did not get dirty as quickly. We then moved these wheels to the back of the robot for more efficiency and reliability. In our latest version of Chicken, we changed the front wheels from wobbly blue wheels to bigger, thicker wheels, which have more consistency.
We were innovative in our design by using a quick attachment system consisting of 2 gears at the top of Chicken where we can attach most of our attachments. This helps us quickly and effectively switch out our attachments. We also took inspiration from sources like YouTube to help us come up with new and original ideas.
This is the attachment that we used to complete the Raise the Mast mission. It's one of the most unique attachments because of how it works. It originally had a less stable design, so we decided to give it a rework by giving it a more stable frame and making it so that it grabs the treasure chest every time.
Discovery. In preparation for FSI, we evaluated our mission runs, and by using Discovery, we modified missions and combined attachments to give us more points in the time given. One example of this is this attachment that completes 3 missions at the same time.
We designed and created a cradle or jig in order to make sure that Chicken started in the right position for its mission. This ensured in case a team member had to miss the competition, everyone would know where to position the robot. During scrimmage, judges liked that we use the cradle and gave us a suggestion to make it more stable and easier to use, which we have incorporated into our design. We then adjusted the cradle and duplicated it for the other side, and then made a specialty cradle for the artificial habitat and traveling to the other side of the board.
We decided to split our 4 dedicated coders into 2 groups, with each group focusing on one side of the board. Each group first started working on missions close to their home area, and then branched out to be able to string multiple missions together. For example, the first missions we coded collects krill, algae, and the marine creature because they're closest to home base and easiest to collect.
We opted to use Python for our coding as we felt that this was easier to control and gave us more flexibility than block code. We focused on what was needed to complete a mission. We kept things simple and built attachments that would work using the same motor. When a mission's code didn't work, we would change one variable of the code ever so slightly so that it would slowly but surely work.
Inclusion. We used pair programming, where one person was the driver or programmer and the other was the navigator. Then we swapped. The driver could debug code, call out and make notes about where it was going wrong, then work together to correct any issues.
Chicken has been designed to be easy to use, with the appropriate file names in order to minimize start time. We did have a problem with Chicken, that it would die mid-route, so we added a function to the start of each mission to reset the motors.
Innovation. We researched different ways to build attachments to use for as many missions as possible. One example of this is our arm attachment, which we used for 3 different missions: the send over of a submersible, changing ship lanes, and seabed sample missions.
Teamwork was a big part of our team, with each team member having different strengths. During each meeting, our robot designers and coders gave the team feedback on any changes in the attachments or the code. Each meeting, we worked together to come up with new ideas for the attachments and improvements on the code.
We have an office portal which we use to share our documents, ideas, and innovations. We also use GitHub to save versions of our code.
At the start of the week, we completed a robot maintenance log where things like checking attachments, cleaning wheels, and motors were logged. We went through each attachment in order to make sure none of them broke or got loose to the point of no longer functioning. This helped identify any issues before they became more of a problem.
Future developments. In the future, we would like to use external sensors. We track away from the sensors that used like to move, get affected by different lighting. So we have started to research the use of these and being able to calibrate them so that they can work in almost every lighting. This should really help a robot with consistency, including any map defects.
During our Friday sessions, after we finish coding and working on the project, we have a little fun by eating pizza and playing games. We also go to CC's at the end of the FOL season as a celebration.
Thank you for listening. Any questions?